The example in red are issues that are related to cable and connectors. On the total initial cost of your project, the cost for cabling is very close to 1%. And when we look, these are a lot of mistakes and common mistakes that are seen. So if the way it's installed, where cable could be continuously exposed or laying in water.
Hello, welcome everyone. Welcome to this webinar about small components that can have a big impact on the ROI of your PV project. My name is Driekes. I'm the managing director here at Sinovoltaics. I hope everyone is comfortable. I hope everyone is doing well. We have 163 attendees here on the webinar from over 40 countries. So it's a real pleasure to have all of you here. And as a special guest, we have Eric Ascomoli from company Stoibli here. Eric,
hello everyone. Hello everyone.
Eric, thanks for joining the webinar. You're an expert on solar cabling, and you've specialized in this very specific field for over a decade. We're very, very glad to have you on the webinar, and I'm sure there's going to be plenty of questions for you. Our CTO, Niklas Weimar, he's also here on the call. He will be available for the Q&A, or if you have any technical questions along the way. Now, to go over the agenda, here's your slide with your profile. Like I mentioned, Eric has been in the industry over a decade, and he's also the president of Solar United. To go over the agenda, so I'll start with a brief introduction of what we see here in Asia during quality inspections at the factories when it comes to solar cables and connectors. And after Eric, it will be your turn. You will speak about topics related to bankability, the main sources of risk when it comes to connectors, and how to avoid these risks. And I've seen that you have some very interesting case studies with some real case failures in the field. So very much look forward to your part of the presentation. We aim to keep the webinar about 30, max 40 minutes, and with a Q&A at the end. Now, when you have questions, please feel free to ask them anytime. Just type them here in the message chat, and I'll fire these questions at Eric, not just at the end, but also during the presentation. So any questions, just type them, and we will try to handle as many questions as we can. So as a start, let's look at some data from our quality inspections at the solar cable factories here in China. Now, just to give you an idea, over the past years, we've inspected about 90,000 kilometers of solar cables. It sounds like a lot, but it's just a tiny proportion of the overall production capacity. We looked at the data, and if you see what are the key defects, then the number one is cables are shorter than you've actually ordered. This is by far the most common thing we see. And the second is off-spec insulation thickness. It's quite common as well, almost 1 out of 4 shipments. And the third are the incorrect or illegible markings on the cables. So if you see how often these occur, then insufficient cable length is the most common, and it's pretty much a classic one, because the way it typically works, you as a procurement, you negotiate a price down with 1%, and your cable length is reduced accordingly. And it really happens. We detect that quite a lot during our inspections. During 61% of orders inspected between 2018 and 19, we see that the cable length is incorrect. Now, if you look at, for instance, the common 4 square millimeter cables, you typically buy 100 meter per drum. That means that you're missing out between 30 and 200 centimeters per drum. And it adds up when you realize you can fit about 143 kilometers in a 20-foot container. Okay. The second most common defect we see are the off-spec insulation thicknesses. And obviously this is also a way for manufacturers to save cost. And we see this in 23% of the orders we've inspected. So it's also a very common thing. And yeah, the specs are usually just on the edge. So factories know exactly how to reduce their material cost and somehow keep the safety a little bit in the back of their minds as well. But this is something to certainly to look at. And the third are incorrect markings. Now, a lot of cables, they're being produced OEM. So the markings, they're usually branded in the name of a distributor, for instance. And in 11% of the inspections, there are mistakes on these markings, or the markings cannot be read clearly. Okay, not a critical thing, but it's common, and that's why we list it here. Now, the final thing about cables is the final defect. It's fortunately not that common, but we see cases of poor conductor resistance, and those are caused by the reduction of the conductor strands, the inner core of the cable. Fortunately, not that common. Overall, we may conclude, no surprises, off-spec cables are quite common, and it has everything to do with cost reductions. Now, before I hand the word over to you, Eric, let's have a look what we see at the factories when it comes to connectors. And I was reading about Stoibli, and I was reading about multi-contact, and that they are the creator or the inventor of the original MC connector. And since 2002, they belong to Stoibli. So you could say that in the solar industry, Stoibli could be considered as the Coca-Cola of PV connectors. And I've also read that Stoibli, they have nearly a 50% market share. But this also means that every year there are gigawatts of modules being produced that have different types of connectors. And that's exactly what we actually see at the factories. So we see lots and lots of different connectors. And let me show you some examples, because I asked one of our team members to go over the inspection reports and send me some examples of different connectors. And at some point I told him he can stop sending me photos because we have enough examples. But you know, there are a lot of different connectors in the market. Eric, did you spot the Stoibli, the original MC4?
Yes, I do, for sure. So number 12 actually we see is MC4 Evo 2, so the latest connector we introduced to the market for 50 volt, and MC4 was on the first slide, showing different type of connectors with the.
I think the second one, right?
Correct, and number 1 is also Evo 2, actually. Yeah.
Okay. Okay, and then we have the same connector listed twice. I couldn't tell the difference, honestly. they all look alike.
We might share some tips how to recognize original connectors, and we are working on that in future also to have also and give let's say, very easy ways and process to make sure that that you get and basically you have original connectors. So we can talk potentially later, or we'll share information later on that.
Okay. So one of the reasons we got in touch, Eric, was some time ago, is that we see a lot of developers of PV plants that they encounter problems with the so-called MC4 compatible connectors, and from what I see, it's a topic that connectors is a topic that few companies really think about, because some of our clients they specifically ask the factory for original MC4s, but actually there's plenty of companies that buy their modules and they just accept whatever connector comes with the modules. And we've very recently this year seen several cases where connectors had quite an impact. Let me highlight one of those cases. I put case study here, but it's more like a story. So let's call it a case story. It's a developer of a 12 megawatt project, Western Europe, was in Netherlands, and the modules were supplied by Tier 1 from China, and the modules were sitting in a warehouse in the Netherlands, and within a week they were going to be shipped to the construction site. And 1 week before the start of the installation, the developer receives an email from the Tier 1 factory saying, we just realized we've sent you modules with 2 types of connectors, and those connectors cannot be used together. So you cannot connect these modules, so you cannot create a cross connection between the 2 different brands of connectors. Now, what really happened was that about half of that order was produced at the Tier 1's factory, and the other half came from an OEM factory. Now, this is very common practice, because all the major factories, they work with a dozen of OEMs. This is something we see all the time. But the OEM, in this case, they used a different junction box and a different connector. So the first question the developer asked was, what if we do connect these modules together? And the factory replied, well, if you do that, then we will void the warranty. So you really cannot do this. And of course, this led to a whole logistical challenge, because for a successful installation of these modules, they had to install 6 megawatt of modules at one side of the field with one type of connector, and at the other side of the field, you had another 6 megawatt of modules, reducing the risk of a cross connection. So this led us to a bit of a journey, and what's interesting is that we spoke with one of the certification bodies about this topic, and I asked, can you not simply test 2 different types of connectors? I give you a connector with brand A and a connector with brand B, and can you not perform a test if they're going to work successfully together? And the answer that I received was very clear. First of all, they said, we don't do that test, because the reason for that is the chance that there will be a problem in the long run is very high. So they don't even want to do this test. So that's just the experience I wanted to share. And I'll leave it at that. And Eric, maybe you can dive a bit deeper into this risk of cross connection. Let me pull up your presentation. Here it is. So Eric, I'd like to hand over the word to you. Please go ahead.
Thank you, Dricus. Thank you for the introduction, and for sure we'll try to deep dive a little bit more into this, explaining why cross connection is not possible and is definitely not working and is not a good option, considering potential issues you might have in the long run. So as you mentioned, small components, big impact. So I do not want to speak too much about us as a company, but This slide is showing in the middle multi-contact, because you mentioned it. So when we invented the first PV connector was back in 1996. This was the very first PV connector. So a product been developed for PV application. Before that, there were absolutely no products for such application. It was the MC3. There's been no MC1, no MC2, MC3. MC3 stands for multi-contact and 3 millimeter, because the conductor cross-section of this contact was 3 millimeter. After that, the output and power of module has been raising, efficiency of module has been growing, etc., so that the current has been growing as well. And therefore came requests for a connector able to transport higher current, as well as some norms changing, saying that a tool was necessary to disconnect the connector, because risk of disconnecting the connector under load. And this is when we developed basically MC4 at the beginning of year 2000. So we are Stably a Swiss family-owned company. We are active in, we have 3 main divisions. So we are part of the connector division with electrical connectors. Yeah, roughly 6,000 employees. Important, you mentioned we have roughly a 50% market share, which is actually a very large volume. We see these days more than 300 gigawatts PV project connected with our products. To give you just some numbers, where do we, or the level of production where we stand currently, we produce and ship weekly roughly 3 million connector sets each week. And we aim to more than double this production capacity from now till the end of next year of 2021. So moving ahead, so bankable, bankability, we see that it's something that is very important these days for a project. This is why you spend attention on selecting models, on selecting inverters. It's important to get the project financed, and very often, so Stably is for sure the most bankable partner for you when talking about connectors. But unfortunately, we realize and we see that people in general are spending a lot of attention to modules and inverter, but less on cabling. And what we say is typically you can't manage the unknown. Why? Because if you don't know the connectors that are built on the module or on the inverter, you might have problems at the end of the day. So, and this EBOS failure leads at the end of the day to higher cost. So the question is then how to balance the CapEx at the beginning of the project development, considering also potential OpEx you might have afterwards that will impact dramatically the profitability and the LCOE. So, and a good example I used to say, and by the way, I'm very glad to have the chance to talk to so much people, considering the current situation with the pandemic. I used to travel almost 40% of my working time being traveling globally. So it's nice to exchange with breakers that is in Asia and all of you around the globe. So that's very nice. I used to take some example like tire on a car. How important is a tire on a car? Would you accept to have different brand or type of tire on your car? Mismatching tire on a car? I would say definitely not, because tire is a safety element. and is bringing the power of the car on the roads. And the connector is pretty much the same. So you can put a lot of attention selecting the right model, the latest technology with high efficiency. But if you don't spend attention to cable, so Drick has also shown some good example of cable, and we see also a lot of issues with cable. But connector in particular, it's a little bit a shame because all the energy produced with the model is going through these small pieces of plastic that is transporting the energy, and we expect this to run for many years. So moving ahead, talking about failure. So we have been a part of an initiatives in Europe that was funded by the European Commission, was called Solar Bankability, where basically we looked at the top 20 technical failures and potential impact on cost. So we had this CPN classification that was the main cost priority number, which is the cost based on failure modes and effects analysis. So we see in red on the right side that the example in red are issues that are related to cable and connectors. And we see then the potential impact in euro per kilowatt peak per year that are related or that are generated by such issues. So if we just take a very, let's say, simple numbers to say, let's consider that the cost of a connector today is roughly $1, and in general it's less than that, but $1. And if we consider that we have 3,000 modules per megawatt, you can easily see that the cost of connectors compared to the total project cost is rather low, and we'll see that afterwards. So here are some pictures, some example of things that we have seen in the field. We all heard about the Walmart issue with Tesla and Solar City. This is on the right hand side, where we see that because of cross connection, it had dramatic issues. And as everyone is calling a PV connector an MC4, very often when people do have issues with connectors, they Google the MC4, and then suddenly you found that the inventor, that the company that is producing MC4 is Stäubli. So very often people are coming to us when they do have problems and issues, and we see a lot of things. So what we like to say is, first of all, is very important from the beginning to select the right product and the right component, but also at the end is important to handle them in a right way. So what we see, the connector just below the title on the left side, it's an original MC4, but the installation has not been properly done, because what we see is that when it rains, we see that the water on the right side of the connector is running through the cable and standing, and humidity standing close to the cable gland, because the radius of the cable, the way the cable is installed, is not done in a proper way. So also potentially over the lifetime of the project, this could generate issues as well. So one thing is selecting the right components and then being sure that they are handled in a proper way. So best practice is also very important. Making sure your EPCs and partners building the projects are also aware about best practices.
From someone in the audience, and he's asking, because you were talking about the way of how the connectors are installed. He's asking, if the connectors are exposed to open sunlight, will it have a significant impact on the system?
No, no. Typically, this is not having impact. Sunlight is absolutely not an issue, or even if it rain on the connector, so it's not an issue. The connector should be laid in water, constantly in water, but it's IP68 certified. I mean, could be in water for or it has been tested for 1 hour, 1 meter deep. So this is not an issue, and sun or UV is also not an issue.
Okay. Thanks.
So it's a short case study in Latin America. We were asked by a company to assess the cabling of a PV project, so a very large project, larger than 500 megawatts. And we did the inspection less than 6 months after the installation was completed. And basically they called us because they had issue and a lot of issues with connectors. And they had several connectors being broken or burned every week. They had inverters showing default. So we have seen that there were several topics or issues like cross mating, but also the quality of the connector was not that good, and basically then it was a huge question for the company, the project owner, to say, well, what should we do? Just replace one after the other the connectors when they are showing problems? But really every week we have seen several connectors showing problems, or just changing the complete system cabling. And at the end they decided to step by step change the complete cabling of the system, because the number of issues and the impact was so high. And also imagine when you have a large PV plant that it's quite far to have people going in the field, identifying which connectors, or on the back of which models do we see a problem. It's also quite, or could be quite costly as well in terms of operation and maintenance cost. So we see here on the same project that that's on 100 megawatts, we collect data and we look at connectors and cabling, also with a thermal camera. So we see high temperature at some places. We see some mechanical damages, but still current being transported. And so these are all the dots and line you see on the project plan. And we had also some string failures that were completely broken. So one thing needs to be clear: when you have no physical damage, but you have high temperature or temperature rising in the connector to a certain point, basically there's no turning back. I mean, this is exponential. Then after some times, then the contact resistance will keep continuously increasing, and this one day or the other over the lifetime of the project, we know that this will have a failure, or the connection will burn. Huh? Maybe let's move to another slide that is just showing at connectors only, it's 0.003%. And looking at the price difference between connectors, we are totally aware that our industry and all players in our industry are having tremendous pressure to keep working on cost reduction and reducing price when scaling production and so on. And we are really committed to that. And also as a company believing strongly in renewable energies, and we have also figures and data showing that we are able to follow this cost reduction curve that we see in the industry. But basically, even a 20–30% price difference between, let's say, a cheap, let's say, Asian manufacturer, not an international connector manufacturer, because there are some other connectors that are potentially not bad. We are not saying that all other connectors than Stäubli are bad. We are not saying that, but there are quite few that you rather not selected for your project. But the potential saving is really small, considering that the performance of the product, but potentially the loss you have in production, in electricity that is generated, and potentially impact on the OEM cost, and not talking about when you have a large issue that could lead to fire, and you need to consider reconstruction of the plant, or even legal costs that could be very, very costly. Yes, that's.
Question. Just to clarify, this slide on the left, it means for connectors, they're only 0.003% of the overall project cost. Is that correct?
Yes.
Okay, so
yes.
What's the price difference between an original MC4 and a cheaper alternative?
So if we look at let's say leading connectors brand, I would say the gap is very low, or we are not more expensive than others. Looking at cheap Chinese or Asian companies, it could be close to 30–40%.
30–40%.
Yes.
Okay.
On the connector only.
Okay. Maybe not related to this, but I got a question in. Have you seen any research? Let me one sec. Let me pull up the question.
I've seen one question related to MLP, module level power electronics. Is that one?
Yes, that one. The one from Kevin.
So if this could prevent fire or really protect, as far as we know, and what we can say is we are supplying companies like SolarEdge, Tigo. So we do have with SolarEdge 100% share, means all products from SolarEdge are equipped with our connectors, and based on the fact that their product is changing the voltage level on the back of the module, reducing the voltage level close to 1 volt. Yes, the risk of fire is reduced dramatically. For other brands, so I see Maxim as well. I don't know Maxim too much, but in general, let's say microinverter or MLP, from a principle point of view, the way they are functioning are reducing potentially the risk of having fire, and seeing also in the US these new requirements for rapid shutdown function that need to be integrated in typical rooftop projects, and this is integrated by SolarEdge, Tigo, and so on. Is definitely working, since it's just switching off models, means there are no currents going through the connector anymore. So it's really protecting against fire for rooftop application, definitely.
Okay, interesting.
So maybe moving to the next slide. So basically, this is it. You better spend some times when planning the project to look at selecting the right components, making sure also with your partners, with the EPCs, that when you select the right product or the product that you select on purpose to fulfill your expectations, that they are also built properly, because this will help to reduce OPEX at the end of the day, and means optimizing or improving the LCOE. He also some points about connectors and yes, component quality, but I do not want to go too much into this. Maybe we have on this slide a very important aspects, which is the core technology of all our electrical connectors. So we are not only active in PV, we are active in many industries, developing connectors for a lot of different applications, where we have parts of connectors that are rotating, that are built in planes or trains and so on. And what the founder of the company developed is the multi-lam, which is our core technology, and which is the component that help to have a good connection with low contact resistance. And what we do here is that we typically developed the multi-lam for the specific application. So when we consider PV, we know it's outside. It should work for many years, since we expect that a system is producing energy for 20 or 25 years. And considering aging, also potentially the multi-lam has been designed in a way that through the day, while eating and producing energy, the multi-lam is expanding, and during night, when not producing energy and the metal, the multi-lam is contracting itself again, is having a self-cleaning, aspect, so that the contact remains very, very good. But this is something that has been integrated in the development of the product. So all competitors or people that has been copying our MC4 and our product have tried somehow to also develop the multi-lam, but not knowing how and the purpose, or how we did the design and the tolerance to achieve this. And there we see on the right side that with a thermal camera, when you look at connectors under current, we see that basically the temperature of the connector is on a very low level. Even the cable is showing a higher temperature than the connector. When a product from a competitor is showing higher temperature, and the higher the temperature means the contact resistance is increasing. So when temperature is rising, I mean, you are losing energy. So at the end of the day, money. These are examples of cross connection. So people with cross connection is sometimes difficult, because for sure it's when people are claiming MC4 compatible products, it's for sure it's difficult for people that are not well educated on connectors and norms for connectors. But basically the norm says, talking about IEC, TUV, as well as UL, that no certification or cross connection is definitely not approved and not allowed. And when we see, and time to time, we see companies providing reports, and if you read carefully or TUV statements, then basically it's not a certification documents. Well, it has been provided by the certification body, but any company could provide products to TUV or UL and say, please test this product under these conditions and do only these sequences. But they're not doing, you know, the whole sequences you should do in a full product certification. So basically, if you read really carefully, it's just a test report that was based on an order from a productor XYZ saying, could you please verify and tell us that connectors could be or are just mateable? Yes, they are mateable, but what happens over the plant lifetime? And here we see, and we see, we do some measurements and some testing that, yeah, when increasing a little bit the current, or let's say doing some heavy testing, that typically the number of fire cases are quite high, and it's just a matter of time. So cross connection is really an issue. You might ask also, well, why is not a standard connector? First of all, we have to keep in mind that we are talking about DC current, and DC current at a level when it's quite dangerous also for human being. We are not talking about the USB connector. You know, we are talking about outside application with different level of also tolerances in terms of production. Our production is fully automated. Really, it's not touched. It's fully automated and controlled by automated system, and we have very tiny tolerances, so that even if you would do a test taking 100 pieces from a competitor's and 100 pieces from ours, potentially, I don't know, a certain portion might work together for a certain time, but also a large portion will show issues because of the tolerances. And we all know that if you have an issue with one single connector on one string, the performance of the whole string is impacted. So then the question is, it worth to try to save on connector when one connector, one issue with connector will impact the performance of the whole string?
Eric, I have a question about this, because of course, if I were building my own PV plant, I would probably want to play safe. And from your story, I understand. Okay, you know, you choose for your original product, and your risk will be acceptable. You know, it's a good product. The reality is, and I think there's somebody in the audience who asked this question, because the reality is, you cannot get original MC4 connectors at every factory or every brand. And sometimes if you ask for it, they might not have availability because you cannot supply the whole industry right now. You have 50% market share with Snowbly, right? So the reality is that a lot of people are ending up with different connectors. That's the reality, right? So and that's also the question from somebody in the audience. So are there any tips for those people that are not able to get these original MP4s, of how they can still play safe by having an alternative product? Maybe you're not the right person to ask, because you are of course representing Snowbly, but there must be other connectors that have an acceptable risk.
Yes, potentially they are. The question is what's the, and I see this in the question that people said potentially when asking for original connector, lead time could be increased. So there's been time where we were struggling a little bit to fulfill all the demands we had, but this is definitely over now. it's also potentially in some cases that that companies like to or it's related to stock of models with different brand of connectors, and asking for alternative. The question is what's the capacity of the other connectors brand, and you know, how are they supplying the different model makers and having enough capacity to fulfill the demand. And also I mean, we produce on 3 continents. We do have a factory here in Europe, but mainly producing for European project and business. We have a factory in North America, and we have one in China. But all those factories use exactly the same equipment, the same machine. So we typically, when we order new production equipment, they usually first come here to the headquarters in Switzerland of Stabile Electrical Connectors. We run them, we test them, and they go through different releasing process, and once validated, it's transferred in one of our factory. So the quality of the connectors, of our connectors, you might get from any of our factories exactly the same. And this is time to time not the case with our competitors, because we fully own all our production equipment, when some of our competitors are just subcontracting this to some companies for the injection molding parts, for stamping metal parts or other components. And there it's sometimes quite challenging to have all these suppliers being on the same level. One example, very important, is we know that some chemicals, oils or some chemicals that are used to like silicon to seal the junction box on the back of the model, or other products that are seen in a model factory, are very aggressive toward plastics. Talking about the plastic used for our connectors, potentially, but also the way and you prepare or you are conditioning plastic is very, very important. In our factory, we have a huge silot where raw material is being delivered, where we completely dry up the pellets, the raw material, the plastic, and then we bring and we are conditioning the plastic to a certain level of humidity. And from this silot to each injection molding machine, the raw material is not in contact with air or with anything, so that it could not be polluted or aggressed by any external factors. I've been visiting a lot of factories producing junction boxes or connectors in China, and many of those you see people I think I even have a picture somewhere where you see people walking through the workshop with bags of raw material. A few years back, you even had some people that were smoking in the factory, and you know, just putting the pellets directly in the injection molding machine. So the raw material could easily get contaminated. So it's difficult then to know if you consider that you typically have 3,000 connector per megawatt, to be sure that all products are good. And then if we talk about gigawatts, it's very large. And when people say, are there research available to show, you know, the performance of connectors compared to other brands? Yes, there are some, but the problem is typically when you get a request for some companies that like to do so, people get what we call the golden samples, means the best of the best. And a good way would be to order batches from different factories, you know, of a connector supplier to test, I don't know, 10 samples or 100 samples from each factory, and to look then not only at the pure performance of one single sample, but to have really an impression of the level of the production. And here what we can say with our full automated production, we really invest massively. We are talking about millions and millions of dollars that have been invested. If you compare then, even if you would take 1,000 pieces with 300 coming from our factory in the US, 1/3 in Europe, and 1/3 in Asia, the gap between the best and the worst one would be very, very narrow, very tiny. Huh? If you do so, and we have been trying and we've been testing competitors' product, because it's also important for us to see and to look where our competitors stands, is the gap could be very, very high. And as mentioned earlier, if you have one bad connector on one string, then the performance of the whole string is impacted. So it's yeah. I mean, if you have you know, a few 100 megawatt projects, just one poor connection per string, it's having a huge impact at the end of the day. So also talking earlier about best practices or connectors being directly on the ground, or the bending radius is also very often an issue. Or you mentioned cable that were too short, right? An example. Yes?
From the audience, how about the bend radius that one should consider? And also I would like to know about whether loops are allowed, because as days progress, the tie gets loosened and the cable pops out, making a loop.
So a loop, potentially, just the loop is not a problem. We see often loops, or when cables are too long, we see people tightening cable and doing loops. This is not a big issue. But what you have to avoid is the picture I've been showing earlier, is if the connector is on the very lowest part of the loop, so that if you have humidity or water coming then to the connector, that is not continuously coming to the connector. This is not good. Moving ahead, we were asked. This was last year by an asset owner they were looking at overtaking, at buying an existing plant. The plant was 5 years old, and they contacted us and asked us also to assess and look at the cabling of the system. So basically, and also tier one model maker, famous EPC, a lot of things were done well. So we didn't have interconnection problem between the model, because it was original MC4 to original MC4. So this was not an issue. But at the end of each string, where you have potentially these cable harnesses that are bringing back each string to a combiner box or to the inverter, there we had cross connection. And this is the picture we are seeing here. And so we took pieces, so the plant was not showing defect, was working somehow properly, but still, because of this cross connection, and because we had this order from the asset owner to really assess and in details the plant, we took samples from also original to original connectors. So after 5 years commissioning and working in the field, as well as this cross connection. And here are the results. So on one end, we have the insulation resistance, and this is given by the 400 mega ohm. This is as a minimum resistance is given by norm. And we know that below this value, it could be potentially dangerous for people getting in contact with such a connector. And here we see that with cross connection, we really have a huge problem. I mean, this being dangerous, if someone would touch this connector, not being protected, it could be very very dramatic. Looking at the contact resistance, so we mentioned, and during certification we had this value on average of 530 milliohm in this case, and after 5 years original to original, we're showing 532, which is very close and a very good performance after 5 years operation. And cross connection, we're showing a very high contact resistance. And based on this, we could really anticipate that it was just a question of time for this showing problems. Difficult to predict if it's going to take another 6 months, 1 year, 2 years, 3 years, but it will be quite obvious that that problem will occur. So we tested that, we completed a report, and then they decided at the end. So they purchased the plant, they changed the cross connection problem, and the plant is working very well. And hopefully at the end of this year or beginning of next year, we really even have some data as to see how much could we improve the production and yes, the productivity of the plant.
So Eric, how often do you believe these cross connections they realistically happen in the field? It must be a very common thing, right? Because which EPC has the same connectors in hand for all the other connections except for the modules? Which EPC has the same connectors to be used everywhere in the field? How common is this problem? Do you have any idea about this?
It's very common. It's difficult to say, or just to give you a number of quotes, how much or how often it's happening. For sure, depend also on the maturity of the market. In some markets in Europe, we see very well-trained EPCs or project developers, owners spending more attention to this because they had basically just too much issues in the past, and they just want to get rid of such issues for the reason we've been showing. So basically not having a huge impact on capex, but generating a lot of problem afterwards.
Well, one other question, Eric. I keep bugging you about these MC4 compatible connectors. There's another question about it. I find this relevant because it's the reality that factories they offer different alternatives, right? They have.
Yes.
Let me read this question. We do see module suppliers' bill of materials, including the third-party laboratory validated bond, which is the CDF, right?
Yes.
Often listing up to 5 different MC connectors, genuine Stoiber, and other so-called compatible alternatives. So that's the reality, right? There is every factory has for every component they're using. They have alternatives. They have different backsheets. They have different types of EVA. That's just because if one supplier runs out of of components, they're not going to stop production. They need alternatives.
Yes.
So I think this is a relative question. Is there a list of approved compatible alternatives? Because there must be more connectors out there that are safe to use, right? So how does that work? Is there a approved list or a certified list of connectors?
So I would say, so basically there are not a approved list of alternatives, and I really like, and I think it's very important for the industry to understand that the word compatible is not appropriate, because it's not accepted, not only by us and other connector manufacturers, well-known and connector manufacturers, but by certification bodies. It's not approved. It's not okay to do so. Typically in the US, so NEC inspectors are instructed to not approve and not release PV plants where you could see cross connection. Yeah. It's definitely not.
Sorry to interrupt, Eric, because that's an obvious one. After all these stories about cross connections, I think the word compatible suggests it can be connected with an original, and we've already seen there's a huge risk to this. But I think what the attendee of the webinar means with this question is, for instance, if another brand has all these certifications possible, why wouldn't they be also a safe choice, right? Because factories are using them. Does it still come with a, you know, there must be other approved alternatives? I mean, it's a bit of a critical question, but the reality is that there are alternatives in the market. So we need to understand, what if people choose these alternatives? What are the risks, basically? There must be also safe alternatives, right?
Yes. So first of all, if you look carefully, I would say that there are not many having the same level of certification. So our products are certified against salt mist spray. So if you install a PV system close to the sea, where you have typically high winds with potentially humidity and salty air that is also very aggressive for plastics and products generally. So our products are certified also against ammonia, showing ammonia resistancy. We did a lot of testing also, again, to test our products in desert area. So if you have high wind and sand have been blown on the connector, and if you look very, very carefully at the different level of certification, and look at this carefully, putting things close together, you'll see that there are not many with the same level of certification, first of all.
Yes. I think that's a good advice to follow the certification route. That's you know, at least then you know if a product has been fully tested or not. That already separates most connectors in that case, if I understand well.
Our company is acting in different business for more than 125 years. We are doing robots, beside connectors, textile machines, and so on. And we aim to keep doing what we do for another long period of time. And means is also, you know, warranty is also a topic, because people potentially could talk about, and there's a difference between a performance warranty and a real product warranty. Some people are claiming, but what we have is, in terms of liability, even though our product warranty is not 20 years or 25 years, but we have a strong liability insurance, so that if it's proven that our product are showing defects, that and defects where it's proven that it's basically been generated by us because of problem with the way it has been produced, engineered, and so on. We are standing for, and we are covered by insurance. So it's not a product warranty. We are not selling it like this, but you rather also take care about sometimes marketing things that some companies are giving, but you know, you have to look behind just the nice title and things people are giving sometimes. Yeah, I think any other question?
Get some very practical things. For instance, this question: how do we identify a genuine Stoibli hand tool?
So on all Stoibli products, you'll find MC or Stoibli logo on it. For it's in the mold, so it's in the plastic for the connector. We even have identification methods when it comes, because we have seen sometimes very good copy exactly of our products, but when we are just let's say looking at each single components inside, we do have a different things to identify if it's a original one or not. Like we have some codes or laser engraving at some place on the connector, or some of the components inside of the connector that let us know where are the components coming from. So the traceability is given from our products totally to the whole value chain. And this is also an aspect. If you want to qualify and make sure that your connector supplier or junction box supplier, because the junction box supplier is typically supplying the model maker, asking for also to audit and understand the process of the company in terms of traceability. For us, we let people visit our factory. I mean, customers or project developers, quality inspections company and so on visit our factory and audit us. This is not a topic, and you'll see that we have ways to identify the products and where it's coming from, which factory, which tool, etc. We have the full traceability of that. This is I would say very few of our competitors, very few of our competitors can do this.
All right, Eric, I have another question. Just go over them a bit, because there's a few more. How do we quickly and effectively identify connector problems in the field? Is it through IR imaging? Well, we do this kind of inspections. You can certainly do that with IR imaging. Do you have any other method, Eric?
Yeah, a turbo camera can also show. If you just look at the connector, yes. could also show.
In this case, it could not be a drone, because you cannot expose all the connectors with a drone. So you need a handheld infrared camera for this.
Yes. I know I'm not doing advertising, but there are some companies developing tools that helps, and you can connect this tool to the string or to close to the inverter, and they potentially show or understanding the IV curve and collecting some data. We are also working on that. It's a little bit early to talk too much about that, but we want to develop also our some solutions to help to recognize issue, or to just give indication about performance of the system. But but there are some solution available to quickly identify.
Okay. Then there's a question about floating solar projects. Question is
Yes.
if there will be new standards or products developed for cables and connectors used in floating solar projects.
Yes, yes, definitely. There are working groups in IEC committee, and we know we are working on it with cable manufacturers. There are some other connector manufacturers involved, and yes, potentially we'll see specific standards and testing for floating solar.
Okay.
I think potentially next year we might have and see more on this.
Okay, I think we're almost pretty much through with the questions. If anyone has any other question, please type it now. There's another one about red cables. I don't use red solar cables too much. Is it true that red solar cables have more losses relative to the black ones because of the ultra-red radiation of the red color?
So we don't like red cable that much, because red, we know that with anything red that is putting outside for a long period of time, that after some times the color will change. And in chemicals means if the color is changing, something is happening with the material. So you have some degradation. That's why we are not saying it's not working, but we are not sure it's or let's say we are not. I think we remove red cable from our portfolio. We know people like that, but yes.
Okay.
Yes.
I think we're through with the questions, Eric. So that means we come to the end of this webinar.
Yes.
Thank you, everyone, for attending. Thank you for the interesting questions. And Eric, thanks a lot for spending some time explaining about the MC4 connectors from Stoibli and giving us all these insights about what to look at and how to avoid any risks. I think it's a really relevant topic, and it's something a lot of people don't think about. So I'm happy we can highlight this and inform more people. So more projects with higher ROIs, and that's what our mission is. So I think I have one more slide. If you would like to get in touch with Eric, I put your details here. Feel free to get in touch with Eric, and the contact details of our team on the right. So thank you everyone for joining, and we hope to see you again during one of the next webinars. Bye everyone.
Goodbye everyone. Thank you, Dricus and Sinovoltaics for organizing the
That's
webinar.
our pleasure.
Thank you.
Bye-bye.
Bye-bye.
Visit Sinovoltaics.com to learn more.